Okay, so first things first, guys, thanks very much for taking time out of your day to click on and watch our online webinar about the upcoming Part L English regulations. I'm going to try and keep this as short and as sweet as possible, give you all the necessary information, remove the hassle, and then let you move on. So, as I say, this Gapotape presentation is going to be on Part L regulations coming into effect, and these are going to be the three key terms we're going to be looking at: performance gap, Part L legislation, and then the solution. So, in case you don't know, the performance gap, this is the difference between your as designed and your as built calculations. Part L legislation, the upcoming regs that forces everyone to address this issue, coming in originally mid to late 2020. It may be slightly delayed due to the current woes we're all experiencing. And then the solution, tested and verified solution to the issue. So, moving on, we're all aware of a U-value calculation and what it looks like, even if you aren't using this specific calculator. But basically what we do is we get all of our R values for the elements we're using, and then we use that to work out an overall U-value of that particular element. And just to try and visualize this process, this is what it actually looks like. We do what's called hot and cold plate testing in order to work out what the R values are of the elements. And then once we work that out, say we get an R value, we then put all these together along with some internal and external surface resistances, and this gives us what that element will do, 0.16. Now, some of you may have already noticed the writing in the bottom corner, and I'll blow it up and let you have a wee look at it. But basically it says that for the purposes of these calculations, the standard of workmanship has been assumed good, and therefore the correction factor for error gaps has been ignored. This is what we have done for years now. We assume that all elements work together in perfect harmony, and that there's no issues caused by the actual combination of them, and that this doesn't affect the U-value. We now know that it does, so architects and builders now have to account for that. So the rationale for this is that in 2012 they started asking this question: how do all these elements work together in situ? What's the practice versus theory between as designed and as built? And let's see if we can devise a test in order to work this out. So the NPL and the BBA started doing what's called the Error Movement and Permeability Report on insulation types. It's a fancy way of saying they were getting in situ U values as opposed to theoretical ones. And in the test, they used multiple types in multiple positions: mineral wool, PIR, and multifoil. And basically, if you want to know what the test looks like, you actually have to build a wall or a roof. You can see it here. This is a roof structure, and they've taken the plasterboard off on the left hand side to let you have a look in the what is actually inside the element. But basically what they've done here is they've built a real roof with the tiles, the battens, the breather membrane, and with the insulation, and then they've tested it. They blow air and heat against it from the cold side, and then they measure the effects on the inside of that room to see what the actual performance is. So they tested multiple insulation types and they all systematically failed. The U values were 80% higher than predicted. And why is that? Well, it's because of the gaps. Basically, whenever I say gaps to people, they tend to think of something as large as 5 millimeters. But to earn heat, they work on the atomic level. They need something smaller than 1 millimeter in order to do the damage. So there's a tiny gap around the edge of all insulation, doesn't matter which type. Once found, the entire current is redirected, and then this is the analogy we like to use, is like a water dam with a gap at the edge. Doesn't matter how tight you friction fit a piece of steel to another, water, air and heat will all find a way to escape through, and then once they find that, the entire current is redirected to that area of weakness, and it maximizes the loss there, and thus even the smallest imperfection, less than 1 millimeter, allows the entire structure to be compromised by up to 80%. Okay, so one distinction I want to make really quick, and this is now where some people tend to get confused, but apologies if you already know it, but I'm going to go over it really quick. There's a difference between something being airtight and something being thermally sealed. Whenever I show some of this testing to people, they say, well, that's because it wasn't airtight. The test actually has an airtight layer inside of it, and this is because it's a thermal issue that's going unaddressed. It's not an airtight issue. So if you look at this, is what the outside of the chamber looks like. You've got your hot side, you've got your cold side, and basically on the cold side there's a fan put in that blows the air at the outside of what would be your tile or your sheathing, and then you monitor the effect on the inside. So here's a wee diagram of what it looks like, and you can see there if you want to pause it and have a look. But basically, there you can see it there was a vapor permeable but not an air permeable layer on it, and other tests have done the same. And basically this is just the point I want to reinforce. It's two different areas of physics that we're talking about here. The test had the air impermeable layer, the insulation type still failed. And why? Well, it's because of thermal bypass, looping and washing. Thermal issues, not necessarily air issues, and these are 13 in total. And if you want to have a wee further look at the test, you can, or if you want to send an email, I can break it down further. But the analogy I like to use whenever I'm telling people about this is that imagine I take you to the South Pole and I wrap you in an airtight layer. you will still be 100% airtight, but you will also get hypothermia. And basically, just because you stop the air movement doesn't mean that you've stopped the heat movement going through that layer. And that's because air and heat are two different effects, and you must be both airtight and thermally sealed, because otherwise, if you were just airtight, we wouldn't have to put any insulation behind the actual layer itself. That's all we need to do. But the solution has to be an airtight and a thermal sealant. And the unfortunate effect of this is that the homeowner has to then subsidise the loss between the gaps. They have to pay in order to make up for that 80% loss. And this also has the unfortunate effect of releasing tons of extra carbon into the atmosphere every year. And it's a position no one wants to be in. The architect doesn't want to be designing a structure that fails. The builder doesn't want to be signing off in a building that then doesn't do the energy calculation it's predicted to do. And no homeowner wants to pay more for their energy bills than they have to. So whenever it came back to looking at how you design out this solution, we thought, how can we do that? Well, can you make mineral wool multifoil more rigid so that it eradicates the gaps whenever it's fitted? Well, there's really no point, because a 100% rigid product such as PIR failed. So you can't make mineral wool and multifoil more rigid, but you can make rigid board more flexible, and thus we came up with this.
The simple application of Gapotape allows you to achieve the full performance of your insulation by eliminating the performance gap. Measure the aperture, top and bottom of your rafters. Take a blended average and cut your insulation panels 8 to 10 millimeters shorter than the gap. Once the insulation panel is cut, make sure all surfaces are free from any dust. Once applied, Gapotape will take out all inaccuracies, be it in the cut of the boards or the rafters themselves. Simply roll out the Gapotape to your required length, cut with scissors, peel back the release paper and fold the wings over onto the panel. Be sure to strike along the wings to create a bond between the foil surface and the glued edge. Repeat on all four sides and simply friction fit your panel between the rafters. As your building settles and elements contract over time, Gapotape will continue to create an airtight thermal seal along all edges, helping you to achieve the full performance of your insulation. Repeat the process to maximise performance on your floors, walls and roofs. Gapotape. Performance Assured Solutions.
So then once we developed this product, we then went back to the National Physical Laboratory and we brought the BBA along as well, and we said we want to redo the same test you did in 2012 onwards, except we want to do a test with Gapotape and we want to do a test without Gapotape to see what effect we have upon this thermal bypass and thermal looping occurring in this area. So as you can see here, this is the specifications for the actual test. We did one with, one without. This is the test without above, and then we redid it with the air and heat movement against the structure. So without Gapotape, once again, there was that 80% loss found in the original testing across the rest of the country and the continent. They found that the slightest wee gaps of less than 1 millimetre, which inevitably occur, allow for that 5 times per performance. We then did a test with Gapotape and it went from 80% loss down to 0. So that simple use of just foil and foam tape made the as-built U values 5 times better. And basically the reason this is particularly pertinent is that in June 2020, it's no longer if you address this issue, it's how you address this issue, due to the multiple parts that are now affecting how architects design their buildings. So I'll show you some of the more relevant areas here. You have what's known as Annex C, which is basically all on insulation gaps. You can pause it there and have a look at it, but to summarise, you now have to show that there's 0 gaps in the actual build. You have to show how you're designing that out, and you have to show how you're allowing for 100% continuous insulation that won't allow for any loss. You also have to show that you're moving towards as-built calculations, so that you're no longer relying on a simple spec and then hope it works. You now have to show how you're working towards your as-built energy calculations. And then you also have to show, once again, that you're improving insulation standards, you're moving towards as-built, you're adopting the newer version of SAP, you're eradicating CO2, and primary energy performance will now be your principal metric. So it's a radical shift towards that we've seen in the past. It's definitely a bigger thing from just simply doing the work on the page. We now have to show that we're working more towards on-site performance. And there's £480 million worth of this material sold in the UK. It might be up ever so slightly, but this is a very commonly used product, which is great news because it means the solution can be rapidly deployed. But one of the unfortunate effects of all installation is that there's a lot of additional extras that people don't necessarily think about. You have to put timber stop battens in, you have to spray foam the gaps, you have to put foil out over, and inevitably these don't work anyway. So it's just an expensive cost that you don't have to incur. We think this is a better solution. Simply putting a piece of Gapotape on the side of the board, pushing it in, letting it be the counter batten, letting it fill the gaps, letting it be your barriers, letting it work over time with the undulations of the timber, just allowing it to offset all those original costs. That's it, guys. That's the end of the presentation. And again, there's a nice wee example of Gapotape working with a retrofit, which is one of the more common areas we'd see, because it allows the rigid installation to work with the disparity and the movement of old rafters. But definitely feel free to reach out to us at info@GapoGroup. Give us a call, look up our webpage, or contact us on any of the social media sites we have. And if you'd like a full CPD where one of our team can go ahead and break down all the technical details and can walk you through the process of it, we're more than happy to do that over, say, send you even like a video of it, or arranging a Zoom call or some type of meeting. But thanks very much for taking time out of your day, and I hope it's been a benefit, and hopefully everybody enjoyed it. Thank you.